Welcome back to the MPLS lab training. In this video, we'll be working on PE1, PE2, and Customer 2, and we'll be configuring Layer 2 services, which is required for Customer 2 in our lab. So let's zoom in here a little bit. Okay, what we're going to be setting up here is this link right here. So PE1 is gig 010, goes over to gig 102 on CE2A. And that's also the same down on PE2, where gig 010 connects over to gig 102 on CE2B. So what we're going to set up is, like it says here, a layer 2 pseudowire, and that's also known as an X-connect. It's just simply a way of being able to set up configuration. So CE2A can have a network, say here VLAN 5, and it's 172.17.10.0/24, and that same exact network can exist at another site. So here VLAN 5 has the same range, the same network, 172.17.10.2, and it's a /24. So that same network exists on CE2A and CE2B. And the way we set that up is we set that up functionally across PE1 and PE2 by using the X-Connect feature. So we'll set that up and I'll show you what that is. We will set this up as a .1Q interface, which means it's just a trunk port. We can send multiple VLANs if we wanted to. So if we wanted to expand that down the road, we could do it. A common use case for this is VMware when they do vMotion and they go ahead and move workload from one place to another. Then that actually requires layer 2 services. But there's also other applications and functionality where layer 2 is beneficial. So this is a way to set up layer 2 functionality using a layer 3 MPLS backbone. And again, that's done with the Pseudowire, the X-Connect configuration. So what we'll do is we'll start out here on PE1, and then we'll configure that and PE2, and then we'll work on the customer site. So this is actually a very easy configuration. As far as PE1 is concerned, whatever it receives on gig 1 or on gig 010 from customer 2 site 1, CE2A, whatever it receives traffic-wise, it would just go ahead and send that right back out PE2 the gig 010 interface. So that just allows whatever customer CE2A sends, CE2B receives, and vice versa. Whatever CE2B sends, it just gets sent back out on the other side, CE2A. So in this case, we will, like I said, set up a .1Q trunk. So let's get to the command line here. We'll start off on PE1. So like I said, we're going to be using gig 0/1/0. And one of the first things we need to do on here is we need to just set the media type. This happens to be an expansion card in the 2921 router that can do either SFP or RJ45, and we're using RJ45 for our lab, so we're going to set that to RJ45. And then we'll go ahead and start configuring the interface. Okay, so we'll set up a description. Okay, and this is just how easy it is. It's just one command. So we've got X-Connect, and we go to the remote loopback address 10.0.0.2, and then we assign a virtual circuit identifier of 5, and we encapsulate this using MPLS. So that's what we need to do there. We can turn up the interface, just say no shut, that'll activate the interface. And there you have it. So just X-Connect, like I said, the remote site, we just assign a virtual circuit identifier of 5 and encapsulate that with MPLS. So you can see here we're on PE1. We're just using loopback 2 as the remote destination for this X-Connect. So that's set up now. We can go ahead and we'll do the same thing on PE2. Okay, set the media type correctly. Okay, we'll just do the opposite on this side. So we're going to set up Xconnect into the opposite IP address to the other loopback 10.0.0.1 with a virtual circuit identifier of 5 and then encapsulate that with MPLS. So it's important that we do keep the virtual circuit identifier as 5, or it basically it just has to match the other side. So we could have used whatever value we wanted there. I just chose 5 for this lab because that works fine. Okay, so what we've done here now is we've set up Pseudowire and Xconnect on PE1 gig 0/1/0 to PE2 gig 0/1/0. And this actually will not work for a third site. This would only work for 2 sites. This is a point-to-point connection. A Pseudowire Xconnect is only a point-to-point connection. If you did have 3 or more, then you would use a different technology called VPLS. So it's configured pretty similar to this, but it is a little bit more advanced. But in any case, VPLS will support multiple sites to have the same network there. Okay, so before we test this, the Xconnect, we actually need to make sure that the customer site is activated and those links are up. If PE1 and PE2, if those links aren't up, the gig 02 links, then it actually won't form the Pseudowire or the Xconnect. So let's go ahead and start working on CE2A, and we'll get that configured, then we'll do CE2B, and then we'll go back to the PE and we'll just make sure everything's working correctly. So let's go over to CE2A now. Just save our configurations here real quick. Always a good habit so you don't lose it. Okay, so here we are on CE2A, and there's nothing real special to do here other than we're just going to go ahead and create a network to send over. So what we'll do is on the diagram here, like we talked about earlier, we'll set up VLAN 5, and this is the address we'll use, 172.10.1/24, and that'll be on gig 102. So the first thing we need to do is we need to go ahead and create a VLAN. Create VLAN 5. We'll call it layer 2 WAN. We're just sending layer 2 across the WAN. Okay, and you'll see that gig 102 right now is just default. Okay, we'll set a description. Like I said, we're going to go ahead and set this up as a .1Q trunk interface to be able to send multiple VLANs. We'll allow it to only send VLAN 5 across for right now. Okay, so what we've done here is we set the switch port mode to trunk. Means it'll force it up as a trunk as a .1Q interface. And we turned off, we say switch port no negotiate, which just turns off trunk negotiation on the other side. So we're manually setting it, so we'll turn off the negotiation. And then we'll allow that interface to come up. So there's the configuration for gig 102. You see this is just like you would see in a standard network where you've building a trunk to another switch or to another device. We'll encapsulate it as a .1Q. We'll set it to mode trunk and turn off negotiation, and we'll only allow VLAN 5 for now. So this just kind of keeps control over it. We could add more VLANs as needed, or we could just take that off and it would allow all VLANs that we create to cross that trunk, but that might not be what we want to go across the WAN. We might not want all VLANs, so we're just going to go ahead and set VLAN 5 for now. So now we need to create the VLAN interface. This is an SVI or switch virtual interface. Just call it layer 2 WAN. Okay, so we'll set the IP address 172.17.10.1/24. We'll turn off proxy ARP, we'll turn off redirects. And we'll bring that interface up. Okay, we'll look at VLAN 5 and you'll see there that we've got VLAN 5 configured. So we can take a look here. So that VLAN is up now. VLAN 5 is up. And gig 102 is up. So those are both up now, both our physical interface and also our VLAN interface. They're both up. So let's go ahead and work on site number 2 now. So we'll come down to CE2B and we'll go ahead and do a similar configuration down there, and we'll set up VLAN 5. But this time we'll use the address 172.17.10.2. So 10.1 was on CE2A, we use 10.2 on CE2B. Okay, so VLAN 5 will create the layer 2 VLAN and give it a name. So gig 102, again, this is just default right now, so let's go ahead and configure that. Okay, set a description. Encapsulate this interface with .1q. Only allow it to send VLAN 5. Activate it as a trunk, make it a static trunk. And turn off switch port trunk negotiation. And we'll bring that interface up. Okay, so there's the configuration. Very simple, straightforward, just like we did on the last one. Let's take a look at the status of the interface. Okay, so it is down right now. We'll need to go in there and see why that's down. Okay, let's just quickly take a look at PE2. Okay, and that would be the problem. Okay, so basically what happened here, we configured gig 0/1/0 and we did not turn it up. I did not turn it up. So let me go ahead and activate that there. And that should resolve the issue. So going back to CE2B now. Now we can see that that interface is up. So that's a good sign. That's why we always test as we go. If we didn't look at our interface there, we wouldn't have known that it's down, and we'd be building the VLAN and wondering why we didn't have connectivity. But by checking that interface right now, we can see that it is up and that it's working properly. So let's go ahead now and configure our VLAN interface, our SVI for VLAN 5. Okay, we'll set the IP address. Turn off redirects and turn off proxy ARP. And then we'll go ahead and bring that up also. Okay, so now we've got VLAN 5. It's configured. Let's take a look at VLAN 5 and see its status. So it is up. It's only up because the physical interface is up. If that physical interface wasn't up, then this SVI actually wouldn't have come up. So that's a good sign. We've got that up. Now let's go back to the PE. So now we know that we have our links are up on both PE1 and PE2. Okay, so now we know that PE1 gig 0/1/0 is up, and also on PE2 gig 0/1/0 is also up. So now let's go ahead and look at the configuration and make sure that our Pseudowire or X-Connect is working properly. So we can just run the show X connect all. You could just specify the X connect that you want, but in this case, it's easy to do all because we've only got one. So we can see that the X connect status is up. So it is up, and that it's going over to 10.0.0.2 and it's encapsulating with MPLS. So that's exactly what we want. So let's go ahead now and take a look at PE2. And just like we'd expect, this site's also up. So it is up, the X connects up, and we are peering over to 10.0.0.1, and we're using a virtual circuit identifier of 5. Okay, so that's exactly what we wanted to see on the PE. There's not a whole lot to do on this side to check it out. It's working right now as we want it to. So our next step would be coming over to CE2A and CE2B and just making sure that we can send traffic across. So let's go ahead and try that out. Okay, so we're on 2A and we're going to go ahead and ping over to VLAN 5 on 2B, which is 172.17.10.2. Give it a second to ARP there, and there you go. You can see that it came through. So let's go over to customer 2 site B. Okay, so we're going to ping 172.17.10.1, source that from, and there you go. So we see that we can ping all the way across. And what's nice here is that we can actually look at the ARP table and it'll actually show the same MAC address. So you'll see here that we've got the actual MAC address of the switch on the other side. So 172.17.10.1, it corresponds to this MAC address right here. So let's go ahead and copy that. Let's go over to that CE2A. And you can see here how on CE2 we have 172.10.1 maps to the MAC address ending in 3FC2. And you can see here when we go to 2A that the 172.10.1, it is also right there. So you're not seeing like a router MAC address or how it does that when you're doing normal routing. You're actually seeing the layer 2 address. So we do have a broadcast domain now, layer 2 broadcast domain that's shared between CE2A and CE2B, and that's going back and forth all the way across. So that's a good sign. That's exactly what we want to have happen. So that's really it. There's not much to it. It works pretty simple, and it's very effective for being able to provide connectivity for different functions and different aspects that you need to set up. And so I hope you've enjoyed the video series. Thank you for joining me. If you've been here with me each time, I appreciate that. I hope you've got a lot out of it. Definitely, if you're watching the YouTube videos, leave feedback if you think there's something that could be improved on or something you liked, and that'll help me as I go forward. So thank you very much. Bye-bye.